So I don't like this trial and error business, especially when they tell me what to round to. Okay? So I would do this for this problem. 9 to the b equals 54. One of the biggest purposes of logs, why I think logs were created, is to find when your exponent is the variable. So I would take the log of each side. Didn't leave myself a lot of room. Sorry about that. And again, we're going to use that one of our log rules to bring that b down in front. So b log of 9 equals log of 54. Divide by the log of 9, because we want to get b by itself. Okay. Now this isn't the same as the change base theorem. It looks an awful lot like what I type in, but I do have to type that all in. Again, remembering to close that parenthesis on the 54. And if we're rounding to the nearest thousandths, tenths, hundredths, thousandths, what should I write? 1.815. Yes. Okay. My second favorite way to solve that problem would be type this into y sub 1, 9 to the x. Type the other half into y sub 2, 54. Okay. Now what I don't like about this way is I need to think hard about my window. If I graph this on a Zoom standard window, I'm not going to see what I need to see. Okay. My line 54 is way up here. Okay. So I'd have to go to Window, Y max, and I would probably put that at 60, and then I could see it. All right, and then how do I find where they cross? Intersect, second trace, or calculate, number 5. And I don't like traveling on the equation, so I arrow up 1 to travel on the line. Just get close and hit enter 3 times. Enter, enter, enter. And there's that same answer. Okay. Brandon, do you have your hand up or no? Oh, okay. All right. Number 7, different technique then that I would use to solve that one. Okay. Remember that we've got change base theorems, but we also have definition of log, those sort of things. So I might see if I could rewrite this exponentially to solve it. See what you would do for number 7. So if we rewrite it exponentially, it would be 4 to the negative third equals x. Again, on our formula sheet, that is the logarithm definition. Okay, and then 4 to the negative third is, you could write the decimal, 0.015625. I don't give you rounding directions, so you could round there. Just choose to round correctly, all right? Like 0.016 would work. Or if you did the math fraction thing, 1/64 is a little shorter to write. Okay. Now, you guys know me well enough to know that I don't make up a lot of problems. Okay. I steal them from the book. And so the reason I'm saying that with number 8 is because I don't like this formula. I don't want all of you girls leaving thinking you're fat. All right. It is a horrible formula. When you calculate the weight of this poor girl, you think, oh my gosh, she's starving to death, okay? Because it gives you a really low weight, okay? 55 inches, if we divide that by 12, that's about 4.5 feet. So she's not real big. But, again, what I'm telling you is your weight here might be low. You know, you're not going to get like 20 pounds. That would be horrible. But it's still low, all right? I look at it and go, that poor little girl can't weigh that much. She'd be too skinny, all right? So just a disclaimer about this formula. I don't like it. I didn't make it up. I don't believe it's true, okay? You should weigh more than that, all right? With that said, let's talk about the problem. So the log of this girl's weight is equal to negative 0.2866 plus 2.722 log of h. Estimate the normal. Again, we're just going to say the too skinny. Weight W in pounds of a girl, h inches tall. Now some of you you're going to get your weight and you're going to go, yeah, that's exactly what I weigh, and I'm going to offend a whole nother group of people. So anyway, I'm trying. Estimate the normal weight, the too skinny weight, of a girl who weighs 55 inches. Okay? So the biggest decision in a problem like this is, where do I plug the 55? Okay? Decide with the people around you, where do you plug the 55? Where does 55 go? H. Okay? So I'm going to put it in here. Now what you need to remember is that when you get this answer, we're not done. Okay? Because then we would have, remember this side still says log W equals, okay? Then we're going to get this number. Otherwise, she would be dead, I'm pretty sure. All right? So go ahead and plug 55 in there to get a number. So when I said this formula was too light, this is not the final answer. So that would be sick to weigh 1.87 pounds, all right? Again, I'm pretty sure there's nothing left of you if you're weighing that much, all right? That's why we've got this log still here. Remember that if you see a log and there's no base showing, what is it really? 10? Okay. So this makes me feel a little better about the problem. I still think it's too small, but whatever, all right? So then we do 10 to the 1.8713, and that would equal this girl's weight, okay? Now remember that we've got that second enter option, so I could do 10 to the second answer, okay? That second negative, so then I don't have to round until the very end, okay? And so, like I've made clear to you, I think 74 pounds is, I guess it was a long time since I was 4.5 feet tall, but that seems skinny to me, all right? So 74.3 pounds like, okay? And I know some of you are going, I weigh 74 pounds, all right? All right, so that is the skinny girl problem, number 8. Go ahead and take a moment to read through then number 9. Look for words like, am I compounding continuously or monthly or daily or that sort of thing? All right, read through number 9. Please look for important stuff. All right, so when I'm looking at this problem, I'm looking for how much money was put in the bank, at what interest rate, for how long, and how was it treated when it was there, okay? Was it compounded continuously like this? That means I have to use a special formula, or daily, or monthly, or quarterly, or whatever, okay? So since it was compounded continuously, I want to use this formula, the continuous change formula, okay, where P is the amount that was invested, R is the interest rate as a decimal, N, whoops, we don't have an N in this one, T is the number of time or the